So Unit 5, odd even functions. This is one that always got me, and I'm like, oh, this one is hard, but it really isn't. We need to find out if each of the following functions is odd, even, or neither. So let's see how that's going to work. First thing I want to do is I'm going to put this over here, and I'm going to say, okay, if we substitute x with a negative x, and we do everything that we're supposed to do, and it comes out with the exact same thing that you started with, then you have an even function. Okay? All right, so how are we going to do that? Well, we'll see. And if you substitute a negative x in there, but you come out with the completely opposite, so all your signs are opposite of what you started with, then you have an odd function. If it doesn't hit either one of them, then it is neither. And that's okay for it to be neither. Now, the reason I have these all moved over is because of fact I want to show you these on the calculator also. Okay, so you got that down? What I'm going to do is we're going to start with the negative 2x squared. Let's see what we have with f of x. So here's our f of x is equal to a negative 2x squared minus x minus, or plus x minus 1. Okay, so what we're going to do is we're just simply going to substitute a negative x in there. So let's see what we get. We're going to substitute a negative x in, and we have negative 2 parentheses negative x squared plus, I'm just going to replace, I'm going to put in parentheses a negative x minus 1. Can't do anything with the minus 1. Alright, so you do know that negative x times negative x is going to be a positive x. So if I simplify this down, I'm going to have a negative 2x squared, but a negative or plus a minus something gives us subtract x minus 1. Alright, so that's our new one. Let's take a look. If we take a look and we start comparing, I have negative 2x, negative 2x. So that's the same. So since the first term's the same, if all of the rest of our terms are the same, then it's going to be an even one. But the minute I get here, those two are different. So I have two that are same and one that's different. So this is actually a neither. Okay? That's a neither one. So we're gonna keep going, and then we're gonna take a look at each one of these on the graphing calculator and see what we got. All right, so let's take the next one. Let me zip down, see what we've got. We've got g of x this time. G of x is equal to 2x to the third plus 4x. Okay, remember what we're gonna do. We're gonna substitute a negative x in here. So we're going to do g of negative x, and we're going to see what we get. 2 times a negative x to the third. Notice how I have that in parentheses, so that's how you would put a negative number raised to a power in a calculator, plus 4 times a negative x. Right, we're just going to simplify. A negative times a negative is a positive, times a negative gives us a negative. So the negative x to the third is actually negative x to the third. So the whole term becomes a negative 2x to the third. Now I have 4 times a negative x. When I simplify that, I'm going to get negative 4x. Let's do a comparison. So if I compare my 2x to the third, I have a negative 2x. That's opposite. I have a positive 4x, but a negative 4x. Each term in my second function is completely different. So what we have is we have a negative x goes into my function. I have a completely opposite function. So this particular one is odd. Is an oddball. Okay? So that's the second one. So let's go and, well, let's finish up because I kind of did a trick. I put some of the functions in the calculator already. All right, so let's go to the next one. The very last one, and see. I think you know what's going to happen with it. But this one is h of x, and h of x is going to be, let's use our green, h of x is going to be x to the 8th plus x to the 12th minus x to the 6th. Okay, so they're all even exponents. Let's see what we get here. We're going to do h to the negative x. We're going to substitute negative x in. So I'm going to have negative x raised to the 8th power plus negative x raised to the 12th power minus a negative x raised to the 6th power. Well, you do know that a negative times a negative is a positive. That means every time that we have an even exponent and we have negative numbers that we're raising to an even exponent, we're going to get the positive number. So in this case, we're going to end up with x to the 8th. Again, we've got an even exponent, plus x to the 12th, minus, because that was there, again, 6 is even, x to the 6th. And let's see what we've got. This is what we have. So do a comparison. Let's do our comparison. What do we have? We have the exact same thing that we started out with. So in this case, we substituted in a negative x, and we ended up with the same function. So this one, you got it, this one is even. So we had, what did we have? Neither, odd, even, right? So we had neither, odd, and even. Okay. So let's see what it looks like on the calculator. The very first one I'm going to put into the calculator is the first one. So I'm going to show you. I kind of did this a little differently. If I put that in, I'm going to actually put it in when I put the negative in. Oh, let's graph this one. I'm going to graph this one. That's all it is a parabola. It is not reflective around the origin, and it is not symmetric to the y-axis. Okay, so let's see. There's nothing special about that one. If we go back and we put in my next one, if I put in negative 2 parenthesis negative x parenthesis, that's a square, so that's easy to do here, plus parenthesis negative x parenthesis minus 1. Let's see what that brings us to. The first one's already there. It doesn't do anything. It just shifts over our parabola. It's the same thing. Okay, so that's where I have a neither. Isn't special. So I'm going to pause you for a second so I can type the next one in. Okay, so look what I did. I put the two functions in for our g of x. The first one I'm going to do is I'm going to actually graph it. I'm going to graph the first one. This is our original. Okay, so there's our original one. Now I want to show you what's going to happen to cause it to be odd looking. Right? I go in. All I did was I substituted in the negative x for that original equation. So I'm going to actually graph it. All right, this is our original one. Now here comes the second one. I'm going to pull this over here and take a look at it. So if we take a look at this for a second, we're going to put it right here, and I'll make it a little bit bigger. This one right here was the original. This is our g of x. Now look what happens. If I start to pull my g of x over, this one here is my g of negative x. So what happens is it's symmetric to the origin, or it rotates 180 degrees. So when it's odd, it's going to rotate 180 degrees, and it's going to rotate around the origin. This was easier if I showed it to you on the graphing calculator I had color, but mine locked up last time, so it couldn't do it. So just remember that that is going to be your odd function. So here's our odd guy. We call him odd. Okay? So I'm going to put you on hold for another second, and I'm going to put the last one in for us to see what happens. All right, so let's finish this up. The y1 I put into, I have our x to the 8th. The y2 I put in, I have negative x to the 8th. So let's see what the original one looks like at first. So let's do that. So let's see what we have. And that's our equation right there. All right, that's the first one. It just goes down and it goes back up. Now, what I did is, because we have them both the same, so what I did was I made the line for the second graph, I made it bold, so you can see it repaint. Okay, so the first one is our y1. That's our y1. Now watch what's going to happen. It's going to take a little bit of time here. Notice how it got very bolded. Still running because I'm marking that up in the corner. All right, so what we have here is we have the exact same thing. Let's bring this down here. I'll show you down here. I've got the exact same line, which is what we came up with when we put a negative x into our h of x. We've got the exact same line. And if you can see it, it actually is itself on top of each other. Okay? So that's how you can figure all of this out.